The Navigation3 library is currently a release candidate, and in this video we are going to explore why is it superior compared to the current stable version, how does it help us support different screen sizes, how we can set up complex navigation graphs including subgraphs, and ultimately, even though this release candidate is not supporting DeepLinks, we are going to sneak peek how we can make it work with DeepLinks as well. Along the way, I'm going to share additional tips and tricks. Let's go. Before we look into the code, let me show you what we are going to be working on. Here I have a grid of artworks, and then tapping on them opens its details, and then going back is also supporting the predictive back. Although this transition is arguably not the best, and we are going to improve that. So going back with the physical back button also works. Now this device is a foldable, and then if I unfold or open it, on the right side we see an empty view suggesting that we have nothing selected, and then if I select something on the left, we are gonna see the details on the right. And making this work with an Nav3 library is trivial, as we are gonna see in this video. To answer the question why it is superior compared to the current stable version is that first, it supports multi-platform, second, it allows us to work with different screen sizes out of the box, and third, it allows us to manage the backstack on our own, as we're gonna learn in this video. So we have total freedom over the backstack, which partly allows us to support deep links on our own. Now let's dive into the code. I don't have anything special inside my activity, I'm only calling a composable which is called uproot. Inside this uproot, I have defined a backstack which is just a remember of a mutable state list of any. And that tells us that our destinations can be literally whatever we want, so we have total freedom over that. There is a tricky point here though, because remember is not going to remember over recompositions. So if I end up rotating the screen or somehow cause some recomposition on the uproot, the whole navigation is going to reset, and that's not nice. What we can do instead is we can remember savable, but in that case maybe we'll need to supply our own serializer and deserializer. Of course, the team behind the Navigation3 library thought about this, and out of the box they support serializing with Kotlin X serialization, and in that case we are going to use the remember nav backstack function. From the signature here we see that it takes in elements which are type of nav key, and if I open its definition, this nav key is a marker interface, which actually allows us to make our destinations extend from this nav key and mark them with serializable, and then this serialization is going to work out of the box for us. Next, I have defined this strategy, which is remember least details scene strategy. If we explore what this does, it returns least details scene strategy. And there are already some standard or default implementations of that. And since this class is public, we can create our own strategy if we want to do something custom. Although the built-in implementations that are coming with the SDK itself are going to support 99% of the cases, because there is support for 2-pane, 3-pane, and that's more than enough to support whatever you are building. Next, I have the nav display function. We can relate this to the nav host that we used to have before, but this is way more superior. We are going to explore in more details probably in another video. But for now, what we need to pass there is a backstack. What happens on back? So here on back, all we need to do is just remove the last item on the backstack. So the backstack is pretty much a stack, so it's a list of items, and then it adds, as we are gonna see when we are navigating, we are adding items in that list, and then what we can do is we can just remove the last when we are navigating back. We are going to pass scene strategy. We don't have to, so this is optional argument, and I am passing here that one only to show that list details pane setup. Then we have an entry provider where we have to define all the destinations or all the screens that are going to be supported inside this nav display. Transition spec, which allows us to specify a transition when opening the screens, and then pop transition, which allows us to specify transition when closing the screens. On top of this, there is also predictive pop transition spec. We're gonna see how to utilize that as well. I do have to mention that similar to the scene strategy, these two are also optional. I don't have to supply them, and in that case, it's gonna fall back to the standard transition that is fade in, fade out, pretty much the same as the nav host as we know. So the mandatory arguments are the entry provider, on back, and backstack. Now let's explore entry provider in more details. As you can see, I'm assigning to it a lambda called entry provider as well. And this entry provider lambda allows us to define the screens or the destinations. what are the destinations we are going to support inside this nav display. My first entry is the artwork destination, and similarly to the composable with the previous navigation where we pass in the generic the destination, we can do the same here. And inside we just define what's going to be the composable is going to be rendered. In this case, I have this artwork screen. I'm not going to get into the details of that one. And that one can navigate to the details, and on navigate to artwork details here, I'm getting back an ID that I have to open, and then all I have to do is just create that destination, which is artwork details, pass there the object number, and I'm just saying on the backstack add. So that's the way to navigate. All we have to do is just call add on the backstack, or if I want to navigate back, remove last one. The second entry is my artwork details destination. The lambda gives me back the destination object, and inside I have the object number that I'm passing. So that's how I can read the arguments that are being passed. A natural question to ask here is, how do I pass these arguments to a potential view model that might be bound to my artwork details screen? And that is already supported in the previous version or the current stable version of navigation, but also it's something that we are going to explore in another video because this one is only around the setup. Next, inside this entry function, I'm passing a metadata, and by using the metadata, I'm telling that this entry is going to serve as detail pane, and it's that trivial. So all we had to do is say metadata list detail scene strategy detail pane, and only by supplying this, we are telling to the Navigation3 that in a setup where the screen is big, use this one as a detail pane. Then the same happens for the entry pane, but here we have a little bit more, because in the list pane, we can also supply detail placeholder, or what happens, what has to be rendered when there is nothing selected. And that's the thing that we are seeing here on the right side when nothing is selected. So if I select, then we are showing whatever the selection is. And that's the detail placeholder. I'm not going to get into the details around the box, and as always, you can find link to the code in the description below so you can explore it on your own. Finally, let's look into the transitions. The transition spec allows us to specify a transition for opening a screen. So what we have inside is sliding horizontally. So that's going to be the first thing that happens. So the screen that comes in is going to slide in horizontally. The initial offset is going to be it. So it will take in the width of that screen, and it will set the initial offset X equal to that width. So it's going to move it to the right, and then it will slide it in horizontally. Then we use together with to define what's going to be the transition of the screen that goes away. And so for the screen that goes away, we are going to scale it out for 90%. So it's 100%, we are making it 90%. And while doing so, this other screen is going to slide in horizontally. Back to the emulator, when I tap, if you pay attention to what happens to this screen, it scales down to 90%, and this other one is flying in from the right to the left. In the pop transition spec, we define the closing animation. So the first thing that happens is we are going to scale in from 90%. So initial scale is 90% because that's where we ended up when navigating somewhere. So when going back, we take it from 90%. It's gonna scale into 100, and that will be together with sliding out horizontally. Again, the target offset X is gonna be it, so it will just move it to the right. However, the problem with this emulator is that it is running on the newest Android, which already supports predictive back, and then the predictive back is something that breaks that transition. So we also have to specify a predictive transition. And inside it, I'm going to take the same thing that we are having for the pop transition, and I'm gonna apply it in the predictive. Now let's run. I'm gonna tap to open. That transition works fine. And if I go back, the transition to go back is fixed as well. Also, if I try the predictive back, that transition is fixed and it works way nicer now. So as we can see, Nav3 makes this also trivial. Now it's important to mention that these transitions are going to apply to all entries inside the nav display by default. What happens if we want to change the transition of one particular screen? In that case, we can supply additional metadata here. And because the metadata is a map, we can just add additional things in there. So if I want to change the transition of this entry particularly, what I can do is I can add here nav display, and then inside we can call pop transition spec, and predictive transition spec as well. And then let's define a transition spec here. And inside I'm going to borrow the transition spec that we have, and I'm going to paste it here. But instead of scale out, I'm going to slide out horizontally. Now, because this one is an exit transition, we have to specify what's going to be our target offset X. Now let's run and see how that's going to look like. So let's pay attention. If I tap, how this screen is exiting is not the same as it was before. So the entering is going to slide in horizontally, but the one that goes away is going to be slide out horizontally by -x. So as we can see, it is being moved to the left as this one is coming into the scene. So the one that is being opened is sliding in horizontally, and the one that goes away is also going to be slid out horizontally in the same direction. Now let's remove this and put it back to regular. Alright, we covered a lot so far, and next we're going to look into defining complex nav graphs with subgraphs, and we're going to sneak peek into DeepLinks afterwards. Back to the main activity, instead of uproot, I'm going to call navroot, which is another composable where I have that complex nav graph setup. So let's dive into that. First, I'm going to run to see what we've got. So in this navigation, our first screen is this welcome screen that has a little button go. Well, I am reusing this screen across multiple places. I'm just changing the color for the simplicity purpose. So this go button has a navigation action that does something. Now, if I navigate, it opens this main screen which has bottom navigation. The bottom navigation navigates internally, as we can see. So we have 3 tabs, and then only the first tab, go, has an action to go somewhere. So these ones are not, but that's fine. So when I click on this one, it navigates further down to yet another screen which opens in details. As you can see, there is no bottom bar any longer. Now we can set up the navigation the way we want. We can navigate, for example, to open it inside this, so that we are going to show the bottom bar as well, but then the navigation is going to be inside this. I'm going to explain it just in a bit. Or we can navigate outside as we are doing here, so then we are sort of going away from that main screen with the bottom bar. To show it visually, this is how the navigation looks like. We have an up graph, which is our main backstack where we are adding screens, and then we have the first screen being added by default. Then the first screen can navigate to another screen, which is the main, and the main then has its own backstack. So it is maintaining the backstack inside that screen. We are going to see just in a bit. And then that main screen can navigate between its own children, in this case these 3 tabs. And then the home navigates away from the main, so we are no longer seeing the bottom bar, to a full screen destination, which is this home details. It's important to notice that this screen is not part of the main of this subgraph. It's part of the global one, so to say. So then we are navigating away from the subgraph into a destination that exists in the global one, in the global app graph. So we have backstack that is maintained on the up level, and then internally inside the main one more. So then this one is navigating away to the previous one, and the previous one knows which screen to open. This is a visualization of how I am projecting these things in my head, and it makes it easier for me to understand what's going on. So maybe it's going to make it easier for you to understand it if you think about it in a similar way. Now back to the code. Let's take a look into this navroot and see what's the setup inside. Before we start talking about the code, maybe you're noticing these green squares that are available here and there in the code, and it says stable. Well, that's a new plugin that was developed recently by Skydoves, and you can find it in the plugins marketplace inside Android Studios. If you go to plugins, then search here in the marketplace for stability, and then it's going to open this Compose Stability Analyzer. It's really an amazing plugin, and once you install it, it is going to appear here on the right side as well. Why I believe this plugin is a must is because it's going to tell you when you have some state is not stable. It's going to point out those things. And even if you know when something is, let's say, going to be checked in runtime and is stable and everything, at least it is going to bring to awareness potential issues, and it's going to make you think. And then you are going to double check whether things are done properly or not. So I believe it's a must to have. Kudos to Skydoves. He's doing an amazing job for the community. So that's something that I wanted to say before working on the code. Now, navroot. Let's look into what we've got inside. I have this backstack, and this time I'm using remember savable, as you can see. I'm again using mutable state list of any, and my initial destination is going to be the welcome destination. Actually, let's first look into all the destinations. I have them in the very same file. You can organize them the way you want. So here I have welcome destination, then the details destination, and then as main destinations I have the root, and then the 3 sub tabs inside. And I have organized them in a sealed class. Now this is not something that you must do, it's up to you, this is just an example, don't take it for granted. Then inside the nav display I have a modifier, backstack, on-back, entry provider, and then the transitions that we saw before. Inside the entry provider I have 3 entries. The welcome destination, which opens a screen that is this welcome, it gives specific color, and then on navigate I am adding to my backstack the main route. The second entry is my main destination main route, and inside I'm only calling the main screen. And then the main screen, as we saw in the drawings and in the demonstration before, it opens the details. It is a lambda that takes in an ID that will be opened in the details, and then it adds a home item details to the backstack, and it uses that ID when creating that destination. The third one is home item details, again screen home item details, and here we are reading the argument that comes in, this ID that we are passing, and then again different color, and on back we are removing the last turnout. So what's important here is to pay attention that we are having these three destinations as we saw also in the drawing before. So this one, then this is the main, which is going to have subgraph, we're going to see, and then the details. And these three are part of our global graph or global backstack. So far so good. Let's see what's the main screen. Here is where the magic lies. So the main screen exposes open home details, which is a lambda that takes in string and it produces unit. Then inside we have bottom bar items. I'm gonna show you what they look like, but they are just data class that has label, icon, and a destination. And let's collapse them so that they are not going to interfere too much. Then I'm remembering the selected item, and this remember actually is problematic because if we happen to recompose the whole thing, this is going to be reset. Then we may end up showing a tab, let's say profile or settings, but on the bottom bar, the selected one will be home. So we can fix that in several ways. We can remember savable, we can hoist the entire state in a view model, and so on and so forth, but that's irrelevant for now. Then inside this composable, I'm remembering another backstack, which I call main screen backstack. And for that one, again, I'm using a mutable state list of any, and then I am passing which one is the current one, what's the selected one. So the selected item destination is going to be the current destination on the main screen. Next, we have a scaffold. So then this scaffold is taking in bottom bar. And as a bottom bar, I have a custom bottom bar, which takes items that we have defined in that list. Then what's going to be the selected one. And then when a selection changes, I'm mutating the selected one. And ultimately, I'm adding that destination on the main backstack. Now, probably you're realizing that this is a mistake because if I keep tapping on the items on the bottom bar, it will keep adding to the stack, and that's not what we want. So that's going to be a homework for you because you have access to the code. You can fix this, or maybe you can tell in the comments below how you're going to approach solving this. It should be trivial. Then inside the scaffold, I'm having a nav display. Inside the nav display, I'm passing the backstack, which is the main screen backstack. On back, I'm removing the items from the main screen backstack, and then as an entry provider again here, I have three entries, the home, the profile, and the settings. So nothing important here, just screen where I'm passing the label, the color, and what happens on navigation. Only the first one has open home item details and it passes their item ID here, so the ID of the thing that will be opened in details essentially. And then the other ones don't have anything, so it has empty navigation block. To explore quickly the rest of the code, it has bottom bar item. The bottom bar item has label, icon, and destination as I mentioned. Then we have the bottom bar, which takes in the items, selected item and on item selected, which has navigation bottom bar. Then for each item adds navigation bar item, and then it adds icon, selected, and on click it just calls that callback. Pretty straightforward. The screen composable takes in label, color on navigate and on back, and then it just has a scaffold where it renders some text and a button in the middle of the screen. Nothing important. Then we have the preview. So the setup of this one, as you can see, is trivial. It has nothing much. So we have a composable, which is a screen, and then inside that screen, we are going to have a subgraph by defining its own backstack that's going to be managed inside that screen. Pretty straightforward. The best thing about Navigation3 is that you own the backstack, so you can manage it the way you want or whatever works for your use case. So if I wanted to navigate to the details inside this one, I would have defined that entry of the details inside here, and then on navigation, I would just add that screen to this main backstack. And in that sense, then this screen wouldn't have been opened in a full screen like this. It would have been opened within this graph, so the bottom bar would have been still visible. Additional thing I want to mention here is that now if I go back from my main screen, it's going to go back to the welcome screen, and that's usually not what I want to do. If this is some sort of onboarding, once I go to the main, that's going to be my destination, so I don't want to see this again when I go back, so I want to exit the application. And to do that, when I'm navigating to the main, I can remove the initial item that was added to the backstack. So the initial item is my welcome destination. After I navigate to main, I'm going to say backstack, remove first or null. Because this is stack and adding is gonna add on top, the first one is still my welcome screen, and by removing that, my main is gonna remain the only one inside the stack. So let's run this. Now if I go to main and then go back, I no longer see welcome. So that's how we can approach creating complex graphs, or at least my approach, and I find this very easy to work with, very easy to maintain over time, easy to figure out what's happening. If you start passing this backstack around, that's certainly an option, but it quickly might become a mess. So be careful whenever you are working with the navigation. Having a single place where you are maintaining the navigation of a particular stack is always easier to work with. Now, the last thing I want to show you is sneak peek into working with DeepLinks. I have this solution in another branch, so check that one out. And the first thing is that if we look into the manifest, I've added a deep link that's going to open the application, which is of a schema RMA, and then the host is open my app. Now let me close the manifest and open the terminal. And this is the deep link that I want to open my application with. So I'm passing down the deep link that should open my application /item ID, which is the item ID of the item that I want to open in details. Now let's run this and open the emulator, and as we can see, that screen got opened. Actually, to demonstrate that, let's close everything. So I have to put it back there. So now if I run this, as you can see, it opens the application. Let me detach it again. It opens the details, but not only that screen, it also builds the entire stack until that screen. So if I go back, it opens my home, and then if I go back, it closes the entire application. So how is this possible? Well, my approach to this is that I have defined a very trivial, very simple object that I am naming DeepLink mapper, and then I have function side resolve DeepLink. So every time a DeepLink opens our application, we can intercept that because it comes through the intent. So the intent is going to have it as a data or data string. We can take either data or data string, and then I can resolve that DeepLink inside this DeepLink mapper. And the deep link mapper is going to be something that will hold references of which deep link is going to be resolved to which stack. So we can use pattern matching, regex, whatever that works for you, to match some particular deep link and parse out all the data out of it, and then build a stack. Because anyway, with the previous navigations, we have to define the deep link in the manifest and also define it somewhere else in the code. This way, it's going to be one central place, this deep link manager, where we are going to have that mapping. And then based on a deep link that comes in, we are going to build a stack, and then we are going to pass that stack down the composition to open particular screen. So we can be very flexible how we are going to do that inside this deep link mapper, or how we are going to build that stack, because the navigation library itself is very flexible. So we own the stack, we can manage and manipulate it the way we want. So we are not going to explore the details of it in this video. So let me know in the comments below whether you are going to be interested, and I'm going to make a full-blown video only about it. Now that's it. I hope I motivated you to try out Navigation3. Let me know how do you find it in the comments. And if you want to level up your Android development game and navigate today's job market easily, find a link below this video and check it out.